12.4 volume of prisms and cylinders. So we're going to start off with some vocabulary. It says that the volume of a solid is the number of cubic units contained in its interior. So if we look at our rectangular prism, what we could do, we could actually draw, I'll continue drawing this back here a little bit and to show you just a quick example of what I'm talking about. So we actually have little squares inside of here, so little cubes. So this is 2, so it goes back here. And we would have this guy go down, he would go down. So here are your 2 cubes if you're looking at them. So we have cube 1 and cube 2. So that's what they're actually talking about when it says the volume. So it's the number of cubic units contained in its interior. So you can see better cubes, what I'm talking about here. We have so 2 units along the base, 4 along the height, and then we have another 2 back here as far as width. So some postulates. The volume of a cube is side cubed. So our volume is equal to S cubed, so S to the third. All the sides of a cube are the same. The volume congruence postulate says if 2 polyhedra are congruent, then they have the same volume. Pretty self-explanatory there. If we have 2 figures that are the same, if they're congruent, they're going to have the same volume. So, but the volume addition postulate says the volume of a solid is the sum of the volume of all its non-overlapping parts. And when we look at the volume addition postulate, we have a couple of these addition postulates. So we're looking at the parts, we add them up, which will give us the sum of the whole, and that is the volume of our solid. So we take our parts, and we find the volume of all of our parts, add them together, that's going to give us the volume of the whole. Example 1, find the number of unit cubes. Find the volume of the puzzle piece in cubic units. One way you could find the volume of this, if we're saying that the interior, the volume is equal to the number of cubic units in the interior, you could physically count all of the individual cubes inside of our figure here. So if you counted them all up individually, so you would go through 1, 2, 3, 4, 5, 6. You could physically, I'm not going to go through, but you could physically count all of them. However, if you didn't want to count up all the individual cubes, the way that I would do this, I would break it down. Remember the volume addition postulate. We find the volume of the parts, and we can add them up to get the volume of the whole thing. So I'm going to start here. I'm going to go from left to right. I'm going to start with this 2. This is 2 by 2 by 2. So that means we have a square. And the volume of a square, remember, volume of a square is equal to side cubed. So it's equal to side cubed. And our side length here is going to be 2. So I have 2 cubed. We get that 2. You see it's a square, so we have 2 along this way, on the height, along the base, as well as back here with the width. So 2. So 2 cubed is going to give us 8. And now I'm going to look at my rectangle here. So I have 1, 2, 3, 4. So I have 4. The height is just 1. So the height here is 1. So the height is 1. And then it looks like my depth here is 2. So I would have volume would be equal to 1. So our height times 4, which is our base, times 2, which would be my depth or my width. That's going to give me 8 as well. And finally, the volume of the last part. I'm going to erase this height measurement just so I don't get messed up. So I can erase that guy. And now I have, it's going to be a rectangle. So I have the volume of this. We're going to look at the base. So our base number would be 1. My height would be 2. And my depth or my width would be 2 as well. 1 times 2 times 2 is going to give me 4. So I could take my 8, add it to 8, add to 4, and this is going to give me the volume, so the volume of the entire figure, which is going to come out to be 20 units cubed. So we're dealing with volume. So our units are going to be cubed. So cubic units is another way to say that. So when we have volume, when we're dealing with volume, the units will be cubed. And here's some theorems for you. It says that the volume of a prism, of the volume of any right prism or right cylinder can be found by multiplying, so the area of the base multiplied by the height. So this is what the formula looks like. It's very, very important to distinguish this. We have a big B and we have our big H. Okay? We have big B and big H. Big B, what this stands for, capital B. Capital B is the area of the base. So capital B is the area of the base. And H, so our H stands for the height. And now when we look at our height over here, when I'm talking height, I'm talking about the physical, the actual height of this guy. So if I look at my rectangular prism here on the right, the yellow figure, my big H would be this dimension. So the big H is this dimension. It's the entire height of their three-dimensional figure. And if we had to find the area of the base, so if we look at our bases, here in number 1, this is just a regular polygon, so we'd have to use our area, so it would be 1/2 base times height. Okay, for number 1, the base here is a regular polygon, so we'd have to use our formula where A is equal to 1/2 multiplied by the apothem times n, the number of sides, times s, which is side length. The base on number 2 is a triangle, so I'd have to use area is equal to 1/2 base times height. And finally, the base here, it looks like a rectangle. So if this was a rectangle, rectangular prism, we would have 3. If 3 is a rectangular prism, we'd have 1/2. Oh my gosh. And so finally, the base on number 3 would be a rectangle, so we'd have area is equal to base times height. Down here for the volume of a cylinder, it says the volume of any right prism or right cylinder can be found by multiplying the area of the base times the height. So in a cylinder, every single time we have a cylinder, the base is going to be a circle. So in the volume formula, it's still volume is equal to capital B times capital H, or big B times big H. And another way you could rewrite this formula is volume is equal to pi r squared times big H, and pi r squared, all that this is here, all pi r squared is just the area of the circle. So the area of your base. So in a cylinder, like I said, everything's always going to be a circle. So the formula is always going to have pi r squared in it when you're finding the volume. Okay, we have a couple examples. It says that to find the volume of the solid. So for A, we have a right trapezoidal prism. So I need to find the area of a trapezoid. And now this is where you're going to need your chapter 11 stuff. Once again, it's coming back. It came back in 12.2 and 12.3, but it's also coming back here in 12.4 as well as 12.5. So the volume for any prism, volume is equal to our big B times our big H. And our big B stands for the area of the base. So my base here is a trapezoid. So the formula for that is going to be, we have 1/2 and we have the height. So the height of the trapezoid, that's going to be the dimension that creates a right angle. So if you look up here, that's going to be 3. So we have 3. And then we need to multiply by base 1, which I'm going to use as 14. And we need to add that to base 2, which is going to be 6. So we multiply all this together. And now my big H is the height of the entire prism. So if we're looking at the height of the entire prism, that's going to be 5. So big B is right here in brackets, and our big H is just the number 5. So we multiply all this together. So you can multiply the inside. So the area of my base is going to come out to be 30. But I can multiply that by my 5. So my total volume of my right trapezoidal prism is going to be 150 centimeters cubed. Remember your units on here. Remember the units. It's centimeters cubed. We have volume, so the centimeters are cubed. Okay, moving on to the right cylinder. We have to find the volume of this guy as well. Remember, the volume for a right cylinder is going to be big B times big H. And our big B in a cylinder, since our base, we need to find the area of the base. That's always going to be pi r. So our r, or the radius here is 9. I need to square this guy. And then I need to multiply it all by 6, and that's our big H. 6 is a big H because you see here it's the height of our three-dimensional figure, so the height of the entire cylinder. And after you plug this into your calculator, you should get 1,526.81, so 81, and it's feet cubed. Dealing with volume, so it's feet cubed. So that's your final answer here for example B. Example 3, the volume of the cube is 90 cubic inches. Find the value of x. Okay, so this one is a little bit different than what we just did, but we have to think back. So it's asking us to find x. So to find x, we have to know what the volume, so the volume of a cube. And remember, that formula is going to be our side cubed. So that's our volume. In the problem, it tells us the volume is 90, so I'm going to plug in what I know. I know 90 is the volume, and I'm going to set that equal to, well, our side length here, they told us, is x, and we have x cubed. So we're trying to get x by itself. For example, if I gave you x squared, you would tell me to get rid of the squared, we have to take the square root. In this question, I'm telling you we have x cubed. So to get rid of x cubed, we have to take something called the cube root, and it looks like this. So you have the radical sign, but you have a 3 right here, kind of where the check mark, right in the point of your check mark. So we take something called the cube root, and so on your calculators you'll have an actual button where you should be able to do cube root of 90, and so x is going to come out to be 4.48. And it's a dimension now. We're finding a dimension, so this is just going to be inches. X is equal to 4.48 inches. And here we have a theorem. It says Cavalieri's principle. So if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So what they're talking about, cross-sectional area. This blue, the blue plane here going through the middle of our rectangular prism and our right cylinder. The cross-sectional area, what it means is the area of this square or this rectangle outlined in red. If this rectangle here has the same area as this circle here, and they have the same height, so H, big H is the same, then both of these figures will have the same volume, even though we have a right prism on the left and we have a cylinder on the right. If those two things are the same, then they're going to have the same volume. Here it says find the volume of an oblique cylinder. So an oblique cylinder. Now remember, the formula for this is still volume is equal to big B times our big H. And since we have a cylinder, I know it's not a right cylinder, but we still have a cylinder, so our base is still a circle. So that means that for big B, the area of the base is still going to be pi times our radius, and our radius here is 4 squared, multiplied by big H, or the height. Now this can be a little bit tricky depending on what they give you, but here they made it easy on us. So between the bases, so this line runs between the bases, and it creates a right angle. Since we have a right angle right here, that means that 7 is going to be our big H, so that's the height of the entire oblique cylinder. So we have our right angle, we can tell right angle between our bases, that's our height. And after you simplify this guy, so I would suggest putting brackets around this, make it a little bit easier on yourself, doing this first and then multiplying by 7. But at the very end you should have 351.86 centimeters cubed. Once again, we're finding volume, so it's centimeters cubed.